How do you interpret AI black box models in pattern recognition? Imagine trying to solve a puzzle where the pieces are hidden inside a box you can't open. That's what working with black box models in pattern recognition can feel like. These models are like complex machines that make decisions based on many layers of calculations. They are excellent at spotting patterns in images, text, or sounds, but understanding exactly how they do it isn't straightforward. Black box AI systems are called that because their internal processes are not visible or easy to understand. You see the input data, like a picture or a sentence, and the output, such as a label or a response. But how the model arrived at that answer remains a mystery. This is especially true for deep neural networks, which are made up of many interconnected layers that process data in ways humans find hard to follow. Pattern recognition is a core part of AI. It helps computers identify things like faces in photos, spam emails, or spoken words. Black box models are very good at this because they can handle high-dimensional data, which means lots of different features at once. But their complexity makes it tough to see why they made a particular decision. This lack of transparency can be a problem, especially when the decisions impact people's lives, like in healthcare or banking. To interpret these models, researchers use techniques called explainable AI. One popular method is called local interpretable model agnostic explanations. It creates a simple, understandable model that mimics what the black box does around a specific data point. For example, it might show that a certain part of an image or a specific word in a sentence was most influential in the decision. Another approach is called counterfactual explanations. These tell us what would need to change in the input for the model to give a different output. For instance, if a loan application was denied, a counterfactual might suggest that reducing debt or increasing income could change the decision to approved. This helps us understand what factors are most important in the model's reasoning. In real-world applications, understanding how black box models recognize patterns is vital. For example, image generation models like DALL-E or Midjourney use complex architectures to create pictures from text prompts. Knowing how they interpret patterns helps improve their accuracy and address ethical concerns. Similarly, large language models like ChatGPT analyze vast amounts of text data to generate responses. Interpreting their decision process can reveal biases or areas for improvement. Ethics play a big role here. When we can't see how a model makes decisions, it's harder to trust it. Ensuring fairness and accountability becomes more challenging. That's why developing methods to interpret black box models is so important. It helps us verify that these models are making fair choices and not reinforcing biases. While black box models often outperform simpler, more transparent models in accuracy, understanding their inner workings remains a key goal. Using explainable AI techniques allows us to peek inside the box and see how patterns are being recognized. This way, we can build AI systems that are both powerful and trustworthy.